All right, so let's talk about a cipher, an actual way of encrypting a message. So the first cipher that we're going to talk about is what's called the transposition cipher. This is probably one of the simplest ways that you can encrypt a text message. So a transposition cipher simply hides a message by rearranging the letters in the message. So let's say we have ourselves a text message that says, "Meet me at the library." All right. So the first thing we need to do is remember that the alphabet that we're using for simplicity's sake only has the lowercase letters. So it doesn't have any spaces, doesn't have any lower uppercase letters. So the first thing we need to do is actually translate this into our alphabet. So it looks like this bit of text right here. All right, so the next thing we need is the key. All right, and remember the key, this was the important part to any cipher. Because the key really is what keeps it secret from someone who is trying to listen in. And the key for the transposition cipher is that both me and my friend are going to agree to use rows of 6 characters each. We'll see exactly what that means in a sec. But this 6 characters bit right here, this is the key of this particular encryption algorithm. So what this means is we are going to write out our message in a bunch of rows, each of which has 6 characters in it. So I write 1, 2, 3, 4, 5, 6 just to keep track of things, and I'm going to write out my message just 6 characters at a time. So meet me at the library. All right, so we just simply write out our message in a slightly different format. So here I've got it written a little bit neater. We can see that it's exactly the same thing. But then the question becomes, how do we encrypt it? How are we using this to encrypt it? And what we're going to do is we are simply going to read down the columns and write out our ciphertext like that. So what this means is the first 3 letters of my ciphertext are going to be M-A-I. The next 3 letters are going to be E-T-B. The next 3 letters will be E-T-R, and so on and so forth. And we keep on going column by column by column this way. So next would be T-H-A-M-E-R-E-L-Y. And this right here would be the ciphertext that we would send to our friend. All right, send via email or whatever. Okay, so this is how we encrypt our text. So then the question, of course, becomes, how do we decrypt? If we are given a bit of ciphertext, how can we take that gobbledygook and decrypt it back into plain text? Well, once again, we need the key. We need to agree with our friend as to how many letters are going to be in each row. So for this one, I'm going to do it differently. I'm going to say that we've agreed on a different key, and there's going to be 4 letters in each row. Okay, and so to decrypt the ciphertext, all we need to do is to write the ciphertext instead of across the rows. We're going to write them down the columns. But in order to do that, we do need to figure out how many rows they're going to be. How far down the columns do we go? So how many rows do we need? Well, if there's going to be 1, 2, 3, 4 columns, and we do a quick count here, and we see that we have 20 letters in total here. Well, then we're going to need 1, 2, 3, 4, 5 rows in order to fit all 20 of the letters in here. All right, so we know we're going to need 5 rows. So in order to decrypt this, really all we do is exactly what we did before, but we're going to go down the rows instead of across the columns. All right, so we take the first 5 letters and write them down the rows, B-O-I-N-G. And 1, 2, 3, 4, 5, all right, and then U, M, L, D, E, 1, 2, 3, 4, 5, Y, E, K, B, L, and then S, M, A, S. And now to read it, we simply go across the rows just like we did before and sort of undo this wrapping process. So BUYSOMEMILKAND BAGELS. That's it out. All right, so now it's still a bunch of letters, but remember, this does make sense. So you need to insert the spaces and figure out where the words are. And that's a bit of a game that you have to play. So buy some milk and bagels. And there's your plain text. All right, so we'll do some practice with this, figuring out how to go from ciphertext to plain text and back again. But some questions that I want you to think about before our next class is, what are the pros to this method of encryption? What do you think the cons are? All right? How secure is this? How easy would it be for someone to break this encryption? How easy is it to encrypt? How easy is it to decrypt? What are some of the advantages and what are some of the disadvantages that you think you see here? And we'll start talking about this in class. All right, so another example of a cipher is what's called the shift cipher. And for the shift cipher, all we do is we take the letters of the alphabet, just as we know them, and shift everything over a certain number of spots. And how many spots we shift them is our key. So for example, right here, we have an example where we have the whole alphabet, all right, written out normally. That's the top row. And then below, we have shifted everything over by 4 spots. So for E, I've shifted that back 4 spaces. So now A is connected with E. E is in the space where A was. And F is in the space where B was. And N is in the space where J was. Basically just take this whole alphabet and shift it backwards 4 spaces. Now, of course, what we're going to do is when we get A, well, we don't have anywhere to go there, so we're just going to wrap it around to the back. All right, and the same with B, C, and D. All right, so you just take your whole alphabet and shift it one way or the other. And the way that you shift it, the direction and how many spaces you shift it, that is your key that you have to have agreed on between you and your friend. All right, so let's take our plain text message here. We write at noon and encrypt it. All right, so every time I see a W, all right, W, I'm going to replace that with an A. All right, for the E, that gets replaced with an I. R is getting replaced with a V. All right, one more. The I gets replaced with an M. All right, and we'll keep on going through here. So D is H, E is I, A is E, T is X, N is R, O is S, I got 2 O's there, and N is R again. All right. So what we have right here is our ciphertext that we can then send to our friend. And of course, to go the other way around, we have our table here, so we can go the opposite direction. Now, when I have my ciphertext, I just want to go look at the bottom row and move to the top row. So every time I see a G, I look for G, that's going to be a C. All right, and when I see a V, where's the V? All right, there's the V. Next to V. So we're looking for C. There's C. All right, and that's going to be a Y. And we keep on going like that. All right, so I'm going to kind of cross these letters off. T is P. X is T, S is O, P is L, S is O, K is G, C is Y, M is, oops, M is I, W is S, J is F, Y is U, and R is letter N. All right, and so this is plain text. We just kind of need to put the spaces in. Cryptology is fun. All right, so with the shift cipher, once you write out the two different alphabets, the plain and the cipher alphabet, it's pretty easy to encrypt and decrypt both ways. All right, so we're going to talk about these. We're going to practice these at next class, but we're also going to talk about security. So what would happen if an enemy stole the ciphertext? Someone intercepted your email, you were passing a note in class and the teacher grabbed it. Would they be able to understand what you were talking about? How easy could they figure it out? Say they don't even have the key. Could they figure it out anyway? And all this leads to something called Kirchhoff's principle, which says that the security of a crypto system is based solely on keeping the key secret, not on the algorithm. Doesn't matter how complex your encryption algorithm is, how much work you do to encrypt or decrypt, or how complicated a computer program you use. If someone has the key, it's game over. All right, so when you are designing a crypto system, you really have to be careful about how easy is it going to be to guess the key or to figure out what the key is going to be. All right, and so this is all what we're going to be talking about when we talk about crypto analysis, which is the study of breaking encryption algorithms.